Hello everybody, I will start my today another live coding session. So in my today's session, I will solve this question. Design search autocomplete system. So in this question, I will design a search autocomplete system for search engine. User may input the sentence at least one word and end with a special character sharp. Okay, so I don't read the whole sentences because this is too long, but instead I will explain the question with my own explanation with some examples. So basically, what I would do in this question is to implement the autocomplete system class. And this is actually you can think of this as a kind of Google search search box. So when user types something like A, then I should return the you know sorry. So basically I start the autocomplete system. There's some argument I have to pass, but I will explain about it later. And say if user input like C, then I have to return the top 3 keywords, which is search in the past. So I should return top 3 hottest words, keywords. And yeah, let's say I type cat. Then if the keyword ends, I will, type sharp. So if sharp is typed, I will return the empty array because the input is finished. And also I have to register the cat word into the autocomplete system and I have to count cat one more time in the index. Okay. Basically, that's what I will do in this question. And a few more things I have to take care is that firstly, this autocomplete systems can be initiated with the seed words, or I should say, the initial word list. So let's say I initiate with cat, which appears 3 times, and also I initiate with cap, which appears 2 times. Let me do this twice and twice. Okay. In this case, when C is typed, I have 2 words whose suffix is C, cat and cap. And both of them appear twice so far, so they're tie. So in that case, I should prioritize cat. Yeah, because it's younger in the ASCII order. So what I should return is cat and cap. And when A is typed the same, cat and cap, each of cat and cap has the suffix CA, which is typed so far. So I should, return cat and cap, sorted by the ASCII order because the frequency is tie. And then I type CAT because cap is no longer, it doesn't have the cat as a suffix, so it should be excluded. I should return cat. Yep. Then when sharp is typed, I should register this cat into the, autocomplete system instance. So cat should be counted as 3 now. This is what I should do. And as I said, this returned array should have at max 3 elements. So I should return top 3 or top 2 if there are only 2 keywords, which has a suffix C. Okay, so I explained the question statement with an example. I hope you understand the question intention of this question. Yep. Okay, so that being said, I will explain the algorithm for this. So obviously the brute force approach is that of the hash map of keyword to frequency. And what I can do is every time the word is input, I have the current ongoing sentence like CA or CAT, and then I will traverse each keyword in this hash map, which represents the past words. Then for each keyword, which is the suffix, whose suffix is the ongoing sentence, I should sort them by the frequency and also the ASCII order of the keyword. Then I should return top 3. So that's a brute force approach. But obviously what I can do is use the try. Because try is, or I should say, prefix tree is built for that purpose. I mean, if the prefix is given, I can find the words which begins with that prefix in the words bank so quickly. So try is the best fit for this question. So what I would do in this question is say I have the cat and cap. In this case, the try should look like this. And because cat appeared twice, so this should be 2, and cap appeared twice, so this should be 2. Yeah. So when you use the type C, I should do DFS from here, and I should find cat and cap, and I should, so then return top 3. And when you use the type CA, now the pointer should be here, and I should do the DFS under this subtree, and I should return cat and cap. And when you use the type T, pointer should be now here, so only I can find that only cat is the word to be returned by doing the DFS from here. So obviously this is the first approach. Or what I can do is, another approach is that instead of, doing the DFS every time, I should cache the keyword which begins with the, suffix C here. Like this. So keywords attribute of the node should have the hash map keyword to frequency. So like this. So I should have this, hash map here. So, yep, twice. Then for cat and cap, obviously this should be cat1. And for this should be cap twice. The good thing of this approach is that once I reach, say, CA, and I reach this node A, I don't have to do DFS from here. All I have to do is those the keywords which begins with CA, which are cat2 and cap2, and returns the top 3. So this is another approach I can take. So So let me go with the second approach. So I will quickly assume the time compressed T and space compressed T. For time compressed T, so under this assumption, this n includes, keywords which were passed as in the constructor. This n includes those keywords which are passed in the initialization. Yeah. So that being said, the time complexity should be so every time input is typed by having the constructor, or I should say, by having the pointer to this. Oh, so sorry. So by holding the pointer to the current node across many input method, I can access the current position in the constant time. Then what I will do is I just have to say sort these keywords and return top 3. So assuming is worst case, all the keywords are included in this frequency map. The sorting takes this much, and I should get the top 3 elements. This is the time complexity for input method. But for sharp, input with argument sharp, it is not. In that case, the time complexity should be, so I have to register the current word whose rank is n into each node until which goes through the current. I mean, each node which is included in the current keyword, finished keyword. The rank is n, and for every time, say, if the current keyword is say cat and then sharp, then I have to traverse C and then register cat, which says error time, and I have to visit A, then taking all of error time to register cat into the cat, keywords of this node A, and then same for T, node T. So the time complexity should be over n error. Okay. Good. So that's the time complexity. Okay, so that being said, let me get started with implementation. Oh, and one thing I have to take care is I cannot register each word under I reach sharp. Obviously because say user type CA and I'm here in the node A. At this moment, I don't know if the sentence should be CAT or CAP, so I cannot determine which sentence it is. Yep. So I have to register sentence once I reach the sharp. Okay, so I will start the implementation. I start with the try node. Okay. Now I will implement the main class, Autocomplete system class. So this is the pseudo root node of the try. And I register each sentence into this try. Oh, let me implement this later. So this is basically what I should do in the main method. Now I will implement the input method. So I will go with the edge case. When C is equal to sharp, this is the end of the sentence. So what I will do is I have to register the current sentence into this try. For that, I have to know which characters are, typed sulfur. I will initiate this. In this way, I can know the ongoing sentence. Okay, then I will register this into the try. Then I will return empty list. But before that, I have to, reset the current pointer. Oh, obviously I have to know this. Okay, so I have to reset current pointer, and also I have to reset the ongoing sentences list. Okay, so this is it. And when C is not sharp, what I should do is first remove the current pointer. So but there are two edge cases I have to take care. The first case is that current node is already none. Or I should say, so let's say I type CAT and okay, let me show us this example. So in line 23 to 25, assuming that the current state of the try is like this, let's say I have the word candy. No, wait. Cut. CUT. Or it's just a chocolate. So in that case, firstly, I move the pointer to C. Yes, from the pseudo root. Then I cannot move the pointer to H because H doesn't exist yet. In that case, I move the pointer to none. So that's one edge case. The case when I have to move the pointer to none. And the second case is that currently the pointer is none. And I have to move the pointer to CHO. Yeah. So in that case also, pointer should be still none, pointing to null. But obviously I have to append the H or O to ongoing sentence. Because this should be used in line 55 when sharp is typed. I have to concatenate the ongoing sentence list chars and then register it into the try. So I have to keep track of it. Okay, so I will think of two edge cases. The first edge case is in this case. So in this case, I cannot move the current pointer, but I just have to append the current C into the ongoing sentence list, and I should return empty array. Okay. The second edge case, self.current is not known, but it doesn't have the given C as a child node. In this case, I should return empty list, and I have to move the pointer to none. And again, I have to append the current C into the ongoing sentences list. Okay. Okay, so I handle the two edge cases. Yep. So from here, in line 70, I first remove the current pointer, and also I have to append the given C into the ongoing sentences list. Then I should return top 3. So this is the keyword and frequency. And I have to sort it in descending order of frequency and ascending order of keyword ASCII. So I should sort this, and I should have the top 3. Yep. And I should return, because this is each element is tuple of negative frequency and keyword, so I should return the list of the only second element in each tuple. Okay, so this is it. Good. So now let me implement the register method. Okay, so in this way, I move the pointer, and I have to append the current sentence. Oh, I mean, increment the counter by times for each node where I'm traversing the characters. Yeah, so this is what I should do. Okay. Oh, so this is incorrect. Okay, so let me execute my code with this. Okay, accepted. Okay, good, accepted. So this worked. Okay. And I can make one, optimization on this. So here in line 77, I sorted the frequency and sentence tuple. I don't have to sort all of them, all of the keywords, or just the sentences. I just wanted the top 3. So obviously I can use the mini heap for this, or it's just a heap. So I will use a heap whose size is 3 while traversing the list. And every time I find the new frequency in the sentence tuple, I push it in the heap. Then, if it is not top 3, I should say, if there are 4 elements in the heap, I should, pop out the worst one. Yeah. Because it can never be top 3. And in that way, the number of elements in the heap is up to 3 all the time. So it takes log 3, which is constant time. And I have to, traverse each element. So this takes only OL time. Oh, but when I push the element in the heap, it should take log n time. 3. So I mean, for popping element or pushing popping out element and pushing in an element is a heap takes row 3 times if the element takes the constant space. But this time, what I will push into is the sentence and frequency, the tuple. And sentence can have up to n characters, so it takes more time than this. Yeah. And yeah, so this is where I have to take care for each operations heap. So this should be O of Ln. Much better. Good. So as I said, I will replace this sorting with using the heap of size 3. Here I will use the Python's heap cube and smallest to get the 3 element, top 3 element. Like this. Yeah. So in this way, I don't have to sort the whole element, but I just have to use the mini heap of size 3. Or no, actually, max heap of top 3, yes, because I have to keep the smallest 3 element all the time. Good. Okay, accepted. Great. So let me quickly wrap up on today's coding practice. So in my today's practice, I solved the question, design search autocomplete system. So in this question, I had to implement the search autocomplete system, the class which represents that. And there are a few functions. So basically, when I type the character into this search box, a kind of search box like the Google search box, I should return the hottest top 3 words which have been typed so far every time I type the character. And when I type the sharp, I can think, or I should say, the autocomplete system thinks that the input of the sentence is finished. So that new sentence should be registered into the system. Like when I type CAT and then sharp, that cat should be registered into the autocomplete system. So my task was to implement this kind of class. Okay. So in my implementation, I used the try, and I, saved each word which was typed software into each try node. So each try node has sentences frequency map which have been typed software and which has the suffix of the current try node. So in that way, yeah, basically when character is input, I move the pointer to the current try node, and then I should return the top 3 of the current node keywords frequency map. Yeah. And when the sharp is input, I should register the sentence into the try. Yeah. And in that way, I could implement this class. And one optimization I made is that when I try to find the top 3 keywords of the current node, keywords or sentences, frequency map, I don't have to sort all the elements. Instead, I can use the heap of size 3. Yeah, so in that way, so finding the top 3 element doesn't take n log n time, but it takes only log 3 time. Yeah, this is what was so good. Okay, so that being said, I finished my today's coding practice. Thank you so much. Bye.